It is about what are lanthanides, what are actinides, right? So here lanthanides are 4F elements, actinides are 5F elements, right? So both these together, lanthanides and actinides, F block elements, right? Both these F block elements are separated below the periodic table, right? To avoid the long formation of a periodic table, nothing is there. They are belongs to the third B group. They are belongs to third B group, and these elements are called as inner transitional elements. Inner transition elements. The next here we have information about alkali metals, alkali earth metals, right? Halogens, noble gases, like this. Here, which are called as alkali metals actually, that which are produced, actually here alkali meaning is what? Plant ash, that the elements of metals which are obtained from the plant ash called as alkali metal family, right? So here 1A group elements are called as here alkali metals. Here alkali meaning is plant ash. Next here chalcogen family. Here chalco means ore product, right? Genus, right? Genus means produced, chalcogenous. Here 16th elements, group elements are called as a chalcogen family. 60th or 16th group elements are called as chalcogenous. Right, then here halogens. Here halo means sea, right? Halo means sea salt. Genus means produced, from the sea salts produced. The elements or the mineral or metal which is obtained from the sea salt is called halogen family, right? That elements which are produced from sea salt are called halogens family. 17th or 7th A group elements are called halogens family. They are called as here halogens family. The next here one more is the noble gases. Also I gave you two more different names: zero group elements or inert gas elements or 8th A group elements. These are all called as, or 18th A called as noble gases. Why they are here? They are actually inert towards chemical reactions. They are inert towards chemical reactions. So chemically least reactive elements are called as here noble gases. They are in the 18th vertical column, 18th group or 8th A group. Right? So they are here helium, neon, argon, krypton, xenon, radon, and organs. So this is the information we learned in yesterday's class, right? The next now here simply we are going to discuss about periods. So what are actually periods? Here periods are what? Actually Mendeleev's modern period table classified or divided into horizontal rows and vertical columns, right? How many horizontal rows? 7 horizontal rows and 18 vertical columns. So here horizontal rows are called as periods, vertical columns are called as groups, right? Then here simply naming that periods or giving a number to assign, right? So here that horizontal rows are assigned with a number that is Arabic numerals 1 to 7, right? Periods represented in the periodic table by Arabic numerals. Look at here. Simply period number 1. Here you have period number 1 just with two elements. They are here hydrogen and helium. First horizontal row. Then second period, it is second horizontal row. It is from lithium to neon. Lithium to neon. Third one is sodium to argon. Fourth period is from potassium to krypton. Next one is from rubidium to xenon. Next sixth period is from cesium to radon. Then last period it is started from francium to the organza, right? So these lanthanides and actinides actually they are belongs to 6th period and 7th period. 57th element to 71st element belongs to 6th period. 89th element actinium to lawrencium they are belongs to 7th period. Right here, look at this only. Here, how many elements are there in the first one? 2. So here, what they are actually here, hydrogen and helium. Their electronic configuration, if you observe, 1s2, 1s1, 1s2. So here, n equal to what? 1. N equal to what? 1. And L equal to what? 0. If n equal to 1, what is the main shell? It is K. So the two elements are belongs to K shell. Okay. If you observe here, second period, it is started from lithium and ending with neon here. Lithium 1 S2 2s 1. Then here neon is 1s2 2s2 2p6. So here observe n equal to 2. N equal to 2 is the main energy level. It takes n equal to 1 K shell, n equal to 2 M shell. Sorry, L shell. Right? N equal to 2 L shell. So how many energy levels are in the second period? K as well as L. N equal to 1 K shell, n equal to 2 L shell. So here simply in the neon electronic configuration, there is 1s2, 2s2, 2p6 configuration. So 1s2 K shell and 2s2, 2p6 is L shell. So K and L are the main shells of second period. As like that, can you see the third period? Same K and L shell. N equal to 3 sir, okay. But in the second period, do you have that d orbital? No, not there, right? So here 3s2 3p6 is there. Okay, here K shell, L shell, then that third shell is M shell here. Here these two K and L are called here inner shells and M is called outer shell, right? So here third period, 2 inner shells, 1 outer shell. Second period, 1 inner shell, 1 outer shell. First period, inner and outer same shell, K shell. Is it clear or any confusion? So any period consists more than one shell. So more than, maybe more than one major shell, right? Or more than number of main shells, more than one. Except the first period, remaining all periods are minimum 2 or more than main shells, right? So that you need to keep it in mind. So here we got shells information, right? So you are able to understand about the shells by looking the modern periodic table, right? So here simply from lithium to neon, how many main shells are there? K and L. So here simply K is inner shell and L is outer shell. So lithium to neon, outermost shell is L shell. From lithium to neon, right? So sodium to argon, outermost shell is M shell, right? So here every time, here K shell, L shell, M shell, and N shell, and so on. So each period ending with the same main shell. Look at. Is it clear? Each shell, each period ending with the same main shell. Starting and ending with the same main shell. Are you clear about that? Are you clear or not? Any confusion is there? Immediately ask me if there is any confusion. So every time new period starts with new shell, ends with the same shell. That you need to have an idea, right? So here you are able to find out number of electrons or number of elements belongs to particularly which cell. For example, here 21st element to 30 element zinc. For which period they belongs to? Fourth period. But main shell, outermost shell is outermost shell. What you can take here, outermost shell becomes this one. Outside. Look at here. For example, zinc I have taken. So nucleus. Okay. How many shells? K shells. 2. L shell. 8. Next. Here, K shell. Maximum it is taking 2. L shell. Maximum it is taking 8. M shell. Maximum capacity is 18. Right? Then one more is required. N shell. Maximum capacity of this one also, sorry, its capacity is 32. 2n square formula. 4 square is 16. 16 twice is 32. Right? So like this. Here how many? 2 plus 8, 10, no? 10 plus 18, 28. 28 plus 2. They are in here fourth shell. So outermost shell is 2. That is N shell. Right? So here shells here called what the third shell, especially it is K, L, M, M shell. Right? Ice, non-ice, inner shell. The elements belongs to this one called as transitional elements. Right? Innermost shell, F block suppose. Right? So here suppose F block. Here F block electronic configuration will be written as here N minus 2. N minus 2 F 1 to 40. Right? 4F. This is what 4F. Here N minus 2. Here these are innermost shell. So they are called as inner transitional elements. They are called as inner transitional elements. Right? So transitional elements, inner transitional elements. Here blockwise classification is there. These are belongs to S block. This is belongs to D block. This is belongs to P block. These are F block. So S, P, D, F. So this is simple outline map iceberg blocks in the periodic table. So here we are discussing about specially periods. What number of electrons are there? Sorry, elements are there in the first period? It is with 2. What about second? It is with 8. What about third? 8. Fourth and fifth? 18 and 18. Next, sixth and seventh? 32, 32. So here 18 plus 14. They are separated at the bottom. Actually, they are belongs to here third group only. Right? So 18 plus 14, 32, 32. Elements are there in the sixth and seventh period respectively. So number of elements identification also important. But sir, why that maximum number of electrons fit into the main shell 2n square not applicable here? Here they are applicable into the main shell, but not into the period. Not into the period. Here periods are classified based on the electronic configuration and groups mainly based on the valency. So increasing order of atomic number, electronic configuration and valency. So these are the two major points we use in the classification of modern periodic table. Right? So that's why you didn't find that number of electrons into that. Right? So third period actually expected 18. So in this 18, only 8 are there in a third period, right? Then 10 in the fourth period. Then in the fourth period, because here after filling 4s, next electron goes into 3d, least n value, and more energy. So Abbo principle concept. That also we followed in a classification of the elements. Classification of the elements. So this is you need to understand, right? So read that points which are given related to periods in your textbook, page number 136, right? In the page number 136, remember and read. So period wise, each shell different. K shell, L shell, M shell, N shell, and so on, like this, right? So in this also, number of elements belongs to which shell you are able to recognize. Then sub energy levels also, like S, P, D, F, with main shell recognition means 1SO, 2SO, 2P, 3SO, like this, 2P, 3P, 4P, and so on, 3D, 4D, 5D, 4F, 5F, like this also you are able to know, right? So energy levels. So like this you are able to recognize the elements in the periodic table, especially in the periods. So are you clear about this discussion? Is it clear? Yes. Right. So now we are moving for another related to this periods only, right? So here simply I am giving you number of elements located or allotted in each period. So period number of elements, and here period also noun is or called as, right? So how we can call that period? That also here I am giving you. So period number one. Period number one. So how many number of elements are there? Can anybody answer me? Number of elements in that? Answer me. Number of elements in the first period.
2.
Only 2. What they are? Helium, hydrogen, and helium. So this period is very, very smaller, short period, very short period. It is called as very short period of the modern periodic table, consisting only 2 elements. The next second one, number of elements?
Sorry, 8.
8. So second period has 8 number of elements. This is called as short period. This is called as short period. What about third period? Number of elements? Same number of elements. So that's why the third period also called as here short period. Same number of elements. Why? Here 10 electrons, 10 elements, electron entry into the inner shell 3D. So they are belongs to fourth period, right? So totally elements in fourth period are equal to 18, right? 18. So it is called as here long period, not longest period, long period, right? Then next here fifth period. How many are there? Same 18, also called as long period. Next sixth, 14 added, where in the F block. So there are here 32 elements. That period is called as longest period, right? Then seventh, actually according to it is a 2014 book, they are following. So that information only given, same number of elements, incomplete, right? 32 actually incomplete. That information given in your textbook. So incomplete period, and it is also called as incomplete period, right? Actually it is complete. All the elements are named, right? All the elements are named. So this is another name of the period, what we can call it as. Do you know this information before? Do you know this information before which we discussed now? Give me your reply. Before this discussion, do you know about this? Long period, very short period, longest period, incomplete period. Maybe you don't know. Okay. So whatever it may be, note down this. Then next here, periods discussion is completed almost, right? There is nothing to discuss from the periodic table. Here, blockwise and electrons, elements also you are able to say, right? How many S block elements are there? S block elements. No answer from your side. I'm waiting for your answer. How many S block elements are there? How many P block elements are there? How many D block? How many F block? So F block are very simple. 2 columns, so 2 rows, 14, 14, 28. Then D block, 4 columns, 40. P block, 6 rows, 6 times, 36. S, 2 each, 7 periods, 40. So total, how many? 8 plus 4, 12 plus 6, 18, 1. 3, 7, 10, 1. 118 elements totally. So you got? Is it clear now? Clockwise elements. Is it clear now? Very good. So this you need to study or recognize, identify in the modern periodic table. Just looking the modern periodic table, much information you are able to discuss, right? No need to by heart them, no need to remember them, just observations from the periodic table, right? The next topic is here, periodic properties. What we're discussing here, periodic properties. So what are the periodic properties? What is actually periodic properties? What is the meaning? Periodic properties meaning. Properties means, okay, we know something it is showing. But periodic properties means, can anybody answer? What are periodic properties? What is meant by periodic property? Periodic means repeated, right? Repeated. So they repeats, what they repeats actually, they are different elements, how they repeat their properties are. Right? So actually the modern periodic classification based on what? Atomic number and change it to electronic configuration concept. So what is electronic configuration? Distribution of electrons into the various energy levels and sub-energy levels and into the degenerate orbitals, right? So that distribution also will learn in the structure of an atom. So here simply the elements which left with the same number of valency shell electrons that are here given as groups. So what is valency? Actually combining capacity, right, with an atom called hydrogen or oxygen. Any atom that may be combining with the hydrogen or oxygen. So that combining capacity we are defining as here valency. So valency shell electrons are responsible for the stability of the atom, right? So all the elements are trying to obtain 8 electrons or simply octet configuration, or here simply they try to behave like noble gas elements having their electronic configuration. So how it can be possible? By losing the electrons or adding the electrons, means gaining the electron into their valence shell. So in this, what they are trying here, they are trying to lose their electrons or gain their electrons. So what is gaining of electron? What is losing of electron? What is valency? Right? On which factors they are depending? So that everything we are considered as property here. So that properties repeated themselves after certain interval. So that is called here periodic property. The property which repeats after certain time or certain interval, that is called here periodic property. Do you got meaning for the periodic property? Have you got meaning for the periodic property? Property name not given, but something we are using, right? So that is here periodic property after certain interval which repeats by the elements called their periodic properties, right? So we will observe that periodic properties in the modern periodic table only, right? So what the periodic properties are here? Simply they are here valence or valency, right? Not valence electrons, valence or valency, both are same only, right? Sometimes you may call that as valence or valency, but not as valence electrons, not as valence electrons. Valence electrons are different from valency. Valence electrons are what? Here number of electrons are present in the valence shell, but valence is what? It's just combining capacity, right? So number of electrons are lost by the element or gained by the element to give electronic configuration as like noble gases, right? So that is valence or valency. The next property is here, its size, or also called as atomic radius. Atomic radius or atomic size. The next here, nuclear charge or ionization energy, ionization potential. Next here, electron affinity or electron gain enthalpy. Next here, electropositivity, electronegativity. Finally, metallic and non-metallic properties, right? Valence or valency, atomic radius or atomic size, ionization energy are also called as ionization potential, electron affinity are also called as electron gain enthalpy, electronegativity, electropositivity, metallic property, non-metallic property. Count them. How many are? 1, 2, 3, 4, 5, 6, 7, 8. Right? So 8 properties are there. 8 properties are there. These 8 are called as here periodic properties. What these are called as? Periodic properties. Periodic means after certain time interval, that entire characteristic properties are repeated themselves within the period or one to the other, that property greater in extent. So that we are learning in these periodic properties about valence or valency, atomic radius or atomic size, right? Then ionization energy or ionization potential, electron affinity or electron gain enthalpy. Next, negativity, positivity, metallic, non-metallic characters. So these are the periodic properties, right? So I will start the discussion in the next meeting. Join immediately.